Hello guys, today we're going to learn about vectors. So what are vectors? I mean, I'm pretty sure if you guys are watching this video, you guys are taking probably physics or probably science related, that you guys know basically what vectors are. Vectors are like magnitudes, length, it shows you direction, and etc. So let me show you what basically vectors are. Vectors are an arrow. Cool. So we call this the end, the tail, and over here the arrow, the head. What does this arrow basically show? Well, it shows you the direction. So I'm gonna write it down. It shows you the direction. And what else? What else does it show you? Well, I believe it shows you the magnitude. How does it show you the magnitude? Well, if you calculate the length, you will get the magnitude. So what do we not know about this vector? Well, we don't know where it starts. So when we don't have a starting position, we always assume it starts from the origin. Therefore, we assume it starts from the origin. Cool. So we have three characteristics of the vector. It shows you direction, it shows you magnitude, and we also assume it starts from the origin when it doesn't tell you where the position starts. So before we go into a little more advanced topic, we will discuss how to add vectors, how to notate vectors, how to subtract vectors. I think I said that opposite way. So we're going to learn how to notate it first, actually. So if we want to notate vectors, right, we would notate it as a square, more like a, I don't know what you call this, but 1, comma 2. So what does this basically mean? Well, this one right here, this is the change in x, and 2 is the change in y. How do you know that? Well, let's say we have P1 of x1 comma y1, and we have another point of P2 of x2 comma y2. Basically, this front part would be x2 minus x1, and this 2 over here would be y2 minus y1. And that is basically what the vector looks like. So vectors are technically kind of a slope, except it kind of shows you the magnitude. Well, how do we find the magnitude? Well, let's see. So magnitude, we represent it with two straight lines between each other like that, equals to square root of this 1 squared plus 2. 2 squared equals 5. 5 square root. Cool. That was pretty easy. Well, how do we add vectors? That is actually a little more simple. So we got vectors like this. We have a vector v, and we got a vector w. What do you see something that you think is important in adding two vectors? So one very important thing that you have to keep in mind when you're adding vectors is that their base has to be touching each other. So in order to add, it has to have a base touch each other. Cool. Well, now how do we add them? Well, we're gonna move the W so that W's tail right here, it touches the V's head. So we're gonna move that right there. Same direction, same magnitude, we're just moving it upwards. I hope this is a little more parallel. And there we go. And then we're gonna call it W apostrophe, like that. And then basically this would be the addition, vector v plus vector w. Wow, we can, wait, this is a little short. Okay. Cool. Alright, well, when you see this graph, what comes into your mind? Well, this shape kind of reminds of a parallelogram, right? That. Oops. Cool. Yes, basically it's a parallelogram. So this is a V, W, that's V plus W. So let's think about it. Let's try an example actually. Let's say we have vector 1, 2, and we have another vector like 2, 4. Cool. So how do we add these vectors? Well, let's say this is something like this, and that's something like, let's see. Well, something, actually I'm going to make this 5. Something like that. I'm going to call this V vectors, I'm going to call this W vectors. So that's going to be W, that's going to be V. So this time I'm going to move the W again, so it's going to look like V, W, apostrophe, and then you make a straight line, that's V plus W. How do we do V plus W? Well, how do we add vectors? Well, it's pretty simple. You just add the front. You add this and this, and then you add this and that, which comes up as 3, 7. That was really simple. Well, we'll try another example, just for the people who's confused right now. So, how do we do it again? We do 3 plus 5 and 4 plus 9. That was pretty simple. And basically we do the subtraction the same way. We can try subtraction right now. Subtraction would work as, let's say we're subtracting this. Then will be 1, 2 minus 2, 5. It would equal to -1 and -3. How is that? That's because this one is 1 minus 2, which is -1, and -3 comes out from 2 minus 5 equals -3. As you can see, vectors are pretty simple, except when you go to parametric equations, and when you're trying to do 3D vectors, it kind of gets complicated. But yes, until now, the vectors show direction and magnitude. It doesn't show you position. So that's why we assume that it starts at the origin. Also, addition and subtraction of vectors are fairly simple. There are going to be multiple times when there's going to be multiple vectors and you're going to have to add and subtract different vectors, but that's not going to be a very difficult problem. So in the next video, I'll be talking about parametric equations, as well as positions, as well as probably 3D vectors. So see you next time.